Hello, we're back to our bank account example, and this time I'm going to implement a new checking account. I'm going to be following our textbook's version of this. I am going to start this all from scratch so that you can see. I'm going to create a checking account. I'm just going to name it checking and use the default setup here. And I'm going to add a few more instance fields as than what our original class diagram had on it, based upon what our textbook is suggesting. So they have a couple private instance fields. One is for the bank fees, and so we have a fee transaction. And actually, the way this bank is set up, the way that it's looking is that you get 3 transactions for free. So that's free transactions. And we are going to also have another private variable or instance field, and that's going to be the bank fees. So this would be the fees, for example, once you get past your free transactions, or it could also be, we could add an overdraft fee possibly, but we're going to have a $2 fee for every transaction past the first 3. And some banks or places do that. Now I need to make that a double. And last but not least, we are going to create another instance field here for keeping track of how many transactions there are. Otherwise, we won't know when to start charging extra money if I'm the bank. We will have a constructor, and the constructor is going to be very similar to our constructor in the bank account. So I'm just going to borrow from the bank account. And that we're going to bring in the initial amount. So I'm going to copy and paste that. Close some of these windows up that I'm not using right now. And so there are changes I will have to make here, but I'm going to have a checking account initial balance. Now, this one's not going to work, and it doesn't work because I don't have the local variable balance. If I hover over this, balance cannot be resolved to a variable. It doesn't recognize the superclass balance, and that's because it was a private instance field. And we've already talked about the fact that we really don't want to access it here. So what we need to do is we need to we need to send the initial amount to the superclass constructor, and it will handle it for us. So we're going to call the superclass constructor initial amount, and then we're also going to set our local transaction account or transaction action count. Transaction count is going to be set to 0. And so that should be our constructor. Now, it doesn't recognize super because I didn't tell it that it has a superclass. I need to do that by saying extends bank account. And now it should recognize that there's a superclass, and we should be good to go with that. With all of these methods, I have a transaction account. Eclipse does have a built-in setter and getter methods I think we could have chosen way back at the beginning. There might also be here some options to generate setters and getters right here. So I could generate setters and getters. I really only want to do that for transaction count. And so I have a setter and I have the getter. Get transaction count, set transaction count. Now honestly, I don't want anybody else to be able to set that transaction account. It should start at 0 in our constructor, and then I should only increment it when we have a transaction. So I'm not going to I deleted the set transaction. So I really just want the getter, but I wanted to show you that feature in Eclipse. Next thing that we're going to do is we're going to start to calculate, or we're going to start to create our deposit and our withdrawal methods. Now, here's where we have a deposit and withdrawal method back in bank account. Okay? So our deposit and withdrawal methods are simply add to and subtract. I'm going to just copy them from bank account. This is really not what you want to do, but I just want to pull them over so we can see them. Okay? And we got a couple of things going on. First of all, you never want to repeat code that's already written. So we want to make a deposit as long as it's valid. And here's where anytime I want to put money in, the bank's going to let me put money in. And so I need to call the SubClass balance, but I also want to keep track of how many transactions that I have. So I need to keep track of the fact that I have made a transaction. I'm going to copy that variable and I'm going to add to that. And then I'm going to call the SubClass balance. So it's going to be super.balance. Actually deposit, because remember I don't have access to balance, and I don't want to have access to balance. You want to keep that protected. So I have to call the deposit method. Now in this particular one, we can call the SubClass after we count the transaction because it's not in the constructor. It's just in the constructor that you want to make sure you call the SubClass first when you're creating or using super. And likewise, we are also going to do the same thing when we have a withdrawal. So I'm going to copy this and I'm going to paste this in, and except that instead of doing a super.deposit, I pasted the wrong thing. Let's try that again. So every transaction gets counted, whether it's a deposit or a withdrawal. And then I'm going to call the SubClass withdrawal. So theoretically, this should now work. I'm going to go write some test cases in my little tester and then test it out. Okay, to finish up, I went back to my bank tester. I did not use a JUnit test, and I just created a checking account, called it Fun Money. It's Fun Money because right now you might be living at home with mom and dad, and so your checking account might be your Fun Money. And so you have Fun Money, and we made several one deposit, several withdrawals, but I went beyond the number of acceptable transactions, and so I calculated the deduct fees just to see what it would do. And when it executed over here, because I had 2 extra transactions, it subtracted out $4. So this is looking like it's correct code. I went ahead and wrote the deduct fees method, and it just checked to see if the transaction count was more than the free transactions, and if so, then it went ahead and calculated and called the super withdrawal. So just a basic checking account. We have not taken into account what might happen if you have an overdraft. We haven't dealt with that at all, and we're not going to in these videos. So overall, you now have a bank account, which is your SubClass. And you have a checking account that extends the bank account and has a subclass. It has overridden, I didn't make a mention of that specifically, but these are what we call overridden methods. We override, or we overrode the base class deposit method here, meaning that it's the same name, same parameter. So when the code is executing, it's going to use, if it's a checking account, it uses a checking account deposit, and then we have to specifically call the super deposit in order to get this to execute. Unlike in savings, when we used when we had in our tester program, when I called add interest or I deposited money in my savings, actually, if I were to do that right here, because I didn't do that, if I do system.out.println, actually back up, if I do college fund dot savings, I'm not thinking college fund dot deposit, and we put in $200 there, and then I'm going to output the savings. So I started with 300, add 200, so I should get 500 right away. If I'm doing this, this is using the SubClass deposit method directly. There is no deposit method in the savings account, and so we should get the 500 and then we add our interest. Rather than down here, when deposit is called, it first executes the checking account's deposit method, and then we call on the SubClass method. So that's a little bit about how inheritance works. That should wrap up our example with the bank account for now.